This week's lesson is about the magnitude of a vector. So the magnitude of a vector, which is notated by the absolute value of v, is the length of a vector from the initial point to the terminal point. So if I have this vector v, it's in absolute value because when we talk about length or like distance, it always has to be positive. You know, if you're driving somewhere, you wouldn't say go negative 10 miles south. You would just say go 10 miles south. So whenever we're talking about length, we always want to keep it positive. And in order to find the length of the magnitude, you can just actually use the distance formula. So if I want to find the magnitude of vector v, I need to use the distance formula, which remember is x2 minus x1. So I've got the initial point in blue and the terminal point in red. So we would just do x2 minus x1 squared plus y2 minus y1 squared. So let's take a look at one of your IXL examples. It says find the magnitude of the vector. Write your answer in simplified form. Well, these are pretty easy and you don't actually need the distance formula because you can just count the units of magnitude or length of the vector. I can still tell that it starts at 0, 0 and ends at 0, 9. So this vector is a total of 9 units. But if you did want to use the distance formula, you could just plug it in. So 0, 0 would be my initial point. So this would be my x1, y1. And then 0, 9 would be my terminal point, which would be my x2, y2. So I could plug it into the distance formula. x2 minus x1. So my x2 is 0. And my x1 is also 0, squared plus y2 minus y1 squared. Well, my y2 is 9, and my y1 is 0. So whenever I evaluate this, I would end up with the square root of 81, which equals 9. So either way, you'd get the exact same answer. So for this example, we need to use the distance formula because we can't just count the length of the vector. It's a diagonal, so I need to use the distance formula. So I can tell that my initial point is at 0, 0, and my terminal point is at 6, negative 10. So here's my x1, y1, x2, y2. So let's just call this vector v. I'm going to start with my x's. x2 minus x1 would be 6 minus 0. And then I would square that. And then I would subtract the y's. So y2 minus y1 would be negative 10 minus 0. And then I would square that. But instead of just typing all of this in your calculator, we only need to look at what's under the radical first because we need to leave our answer in simplified radical format. So no decimals. Alright, whenever I evaluate 6 minus 0 squared plus negative 10 minus 0 squared, I get 136. So my answer would be the square root of 136. But I need to make sure that I can't simplify this anymore. And we actually can. So remember, to simplify a radical, you have to think about what perfect square would divide evenly into 136. So up here at the top, let's go over some perfect square numbers again. I'm going to write them in green. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and then I could do 25, 36, etc. I could just keep going. So these are all of my perfect square numbers. So out of these numbers up here, I know that 136 is divisible by 4. So I can break this up into the square root of 4 times the square root of 34, because 4 times 34 is 136. And then one step further, I know the square root of 4 is 2, and then I would just leave the square root of 34 as is, because the only factors of 34 are 2 and 17, and neither one of those numbers are perfect squares. So my final answer would be 2 times the square root of 34. Alright, for this problem, we're still finding the magnitude of a vector, but this time we no longer have a graph. We are just given some coordinates. So I can tell that my initial point is at 7, -8, so this would be my x1, y1. And then my terminal point is at 7, 1, so that would be my x2, y2. So plug it into the distance formula. X2 minus x1 would be 7 minus 7 squared, plus y2 minus y1 would be 1 minus -8 squared. So once again, only evaluate what's under the radical first. So whenever I evaluate 7 minus 7 squared plus 1 minus -8 squared, I would get 81. So my answer is the square root of 81. Well, thankfully I know that the square root of 81 is just 9, so I don't have to worry about simplifying this anymore. My final answer would just be 9. Here's our last example. We still need to find the magnitude of vector wx. So w is my initial point. Here's my x1, y1. And x is my terminal point. So that would be my x2, y2. So let's go ahead and plug them into the distance formula. x2 minus x1 would be 5 minus 7 squared plus y2 minus y1 would be 3 minus -7 squared. Once again, only evaluate what's under the radical first. So whenever I type in 5 minus 7 squared plus 3 minus -7 squared, I would get 104. So now let's think about if I can break down the square root of 104 anymore. So let's go over our perfect squares again. I'm going to write them in green. 1, 4, 9, 16, 25, 36. And I could keep going, but we don't need to. So let's think about, out of these numbers, what number would divide evenly into 104? And I know that 104 is divisible by 4. So we can break this into the square root of 4 times the square root of 26, because 4 times 26 is 104. And then let's go ahead and simplify that. The square root of 4 is 2, and then I would just leave the square root of 26 as is, because the only two factors of 26 are 2 and 13, and neither one of those are perfect squares. So my answer would be 2 square roots of 26.